Welcome everyone. Thank you for joining us for today's webinar. My name is Ashley Limbers and I'm the Marketing Coordinator at Total Computer Solutions. Total Computer Solutions is a full service provider of IT support and services, including network security, cloud computing, network administration, and managed backup services in Central North Carolina. Today we are hosting How Wi-Fi Can Boost Your ROI, presented by Ian Collins. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in your Zoom control panel, and we'll bring them up at the end of the presentation during our Q&A. Now, without further ado, we will turn the time over to Ian. Our presenter today has his bachelor's degree in cybersecurity. He has a Security Plus certification and a rich background in wireless technology. Ian began with signals intelligence in the Marine Corps and expanded upon his experience to successfully architect numerous Wi-Fi designs in various environments.
Thanks, Ashley, for that introduction. Good morning, everyone. Welcome to our webinar on how Wi-Fi can help boost your ROI. In this presentation, we're going to look at understanding the functions of how Wi-Fi works, learn the basics of real-world Wi-Fi deployments in small and medium-sized business environments, and we're going to look at the requirements for successful wireless integration. All right, so we're going to understand some of the basics of Wi-Fi. Wi-Fi can often be forgotten or a misunderstood tool that can greatly benefit any business across multiple industries. Its overlap and ubiquity in the consumer market means that the general understanding of it can be a little bit skewed. Wi-Fi and wireless technology offer many benefits that can extend far beyond simple internet connectivity. It's an extension of your network down to every device. Wi-Fi uses radio waves to carry data through the air to remote devices, and it's important to understand that the environment influences these waves as they propagate through the air. Depending on the type of environment, there may be more equipment necessary to broadcast a signal and have a successful deployment. The Institute of Electrical and Electronics Engineers, or IEEE, has been the entity responsible for creating the standards that apply to Wi-Fi. The modern standards of Wi-Fi all follow the same naming convention of 802.11x, and that X is replaced by some letter. And these can often be found on the labels of wireless equipment. These generations are also given familiar names such as Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, and this is by an organization known as the Wi-Fi Alliance. It's an industry-recognized nonprofit that certifies Wi-Fi products. Wi-Fi has evolved a lot over the years. The throughput capabilities have increased dramatically, and the ability to service more client devices continues to grow as the Internet of Things, or IoT, becomes more congested. Wi-Fi also has outgrown its radio frequency limitations as different bands of the radio spectrum have become available for use. The original 2.4 gigahertz band brings the capability to broadcast at a distance, and utilizing multiple data streams within that band means that low bandwidth limitations can be circumvented, but this is to a degree. Wi-Fi 4 is characterized by the 2.4 gigahertz band and the latest in standards for its bandwidth. It utilizes multiple data streams to create acceptable throughput. Once the 5 gigahertz band was open to Wi-Fi, it meant there could be more bandwidth across an even greater number of channels. Applying the same multiple stream solution amplified the throughput that much more, and has created a solution that has sustained for nearly a decade. Its only limiting factor has been its range, which is relatively short, which keeps the older 2.4 gigahertz generation around to pick up the slack for some of the more distant devices. This also keeps separation of clients, which eliminates traffic congestion and keeps the slower devices relegated to the slower bands. Wi-Fi 5 is characterized by the 5 gigahertz band, and it's the standard in modern Wi-Fi protocols. It utilizes full channel bandwidth and multiple data streams to provide excellent service. It succumbs to the pitfalls of using higher frequency over its 2.4 gigahertz counterpart, which ultimately is its range. So a new generation of Wi-Fi is on its way, known as Wi-Fi 6. It aims to expand the use of the spectrum to include the 6 gigahertz band and add an additional method of handling wireless clients. Its greatest benefit will be seen in high density areas. Wi-Fi 6 is characterized by spanning both 2.4 and 5 gigahertz, and it also includes a 6 gigahertz band made available last month by the FCC, who decided to open up an additional 1,200 megahertz of bandwidth. All right, another poll question. How often do you budget to plan, how often do you budget a plan to update your wireless infrastructure? Every 3 to 5 years, every 5 to 10 years? Or what do you mean I got to update wireless? Good. All right. So a good plan to budget for an upgrade in 3 to 5 years is right where you should be. Typically, the devices that come out, they have a lifespan, and that 3 to 5 year lifespan is right where you should be at. All right. So we're going to look at some real world Wi-Fi deployments. You got to think about the solution. What best fits your needs? Not everyone needs wireless, and of those that do, there are different wireless technologies to meet objectives. So it's important to understand what types of wireless technology are out there to be leveraged in your own environment to really harness its potential. RTLS, or real-time location services, is a function of wireless that allows you to track objects throughout space. RTLS via Wi-Fi is useful in high-density environments because it utilizes access points that are located throughout your environment. It's important to understand the accuracy requirements of the application because RTLS via Wi-Fi is not defined for precision. It can give you some good generalizations, but it's not pinpoint accurate. One of the other solutions is ultra-wideband. Ultra-wideband technology utilizes a very wide bandwidth signal at a very low energy. It can be used for greater precision. Because of its low energy, it's used for very short range in line of sight. Through lower bands of frequencies, have greater potential to pass through objects. It's a highly scalable solution that can track hundreds of assets across a large area with great precision. And it'll benefit the most in manufacturing and warehousing environments. Another wireless technology that can be leveraged to increase efficiency and productivity in your business is the use of RFID technology, or like the RFID tags. Most people are familiar with RFID tags and readers, and in many warehouse environments, employees need the ability to scan material, but RFID can also be used in these settings to assist in locating and tracking material as it moves through a warehouse. So as far as your environment, wireless can provide a benefit to any network and many different types of networks. It's important to understand your environment and your application in order to better create a solution that returns value on your investment. Utilizing wireless in an office can increase productivity by not tethering employees to their desks. Laptops can be taken to conference rooms. Desks can be switched around without cabling. Adding new employees is easily scalable without running any additional cables. Utilizing outdoor access points, the network can be extended to where running cables might not even be possible. Examples of this can be seen in campus-wide Wi-Fi settings at educational institutions or mechanic shops or large trucking companies. Trucks may need updates or diagnostic tools without the need to pull them away from the bay and take up resources. Warehouse and production can see the greatest return when implementing a wireless system. The use of RFID scanners across different types of applications means that they need to be mobile and have good connectivity everywhere. In a production environment, the ability to track product or materials throughout the facility using Bluetooth, RFID, or ultra-wideband can keep your production on schedule and ensure material is where it's supposed to be when it's supposed to be there. For example, one of our clients is in a distribution industry, and a reliable wireless network is crucial to their success. The Wi-Fi in their warehouse needs to cover every square inch to support the accuracy of their selectors. Errors in picking processes or inventory systems are costly to that business. For daily operations, the IT director of that particular company knew that they needed a wireless network capable of handling their needs now and in the future. After implementing a new wireless infrastructure, they were able to create guest networks and support more than 500 wireless devices through the facility. The updated system also allowed the company to get a high-level overview of its infrastructure and web access. If there's an issue with communications, internal staff can see where the problem is and repair it. The reliable wireless network gives them the tools that it needed in order to implement new technology and grow revenue. Another instance is healthcare. Using RTLS in healthcare, organizations can utilize data to provide insight into the management of medical equipment, staff, and their patients. Integrating this with our with other healthcare IT systems can help create a lasting and meaningful change towards efficiency and improved services. And keep an eye on where your patients are going. So it's vital to see Wi-Fi as an integral part of the organization's network. Often it's looked at as an addition, a service is simply slapped on top to provide general wireless connectivity, but all angles of the network need to be considered, including the way clients connect to the security protocols in place to keep them secure. The most critical factor in a wireless environment is the requirements. It seems almost like a gimme, and for that reason it's overlooked more than anyone is likely willing to admit. Integration takes into consideration these requirements and is the seamless addition of wireless into the overall network. What are the applications being used over the Wi-Fi network? What kind of traffic does this create? It's crucial to take into consideration how much network throughput will be required based on the types and the numbers of applications that are running on it. Same with client devices. What are they? What are the client devices? This is one of the more critical questions to ask yourself when considering your wireless deployment. What devices will be connecting to the network? For example, an aging wireless infrastructure may not provide service that's acceptable to specific client devices, looking at you, iOS and Apple. Some devices may not support connecting to outdated infrastructure for several reasons. That's a big problem with Apple's actually. This problem exists in reverse as well. Upgraded Wi-Fi infrastructure may not support older protocols and older clients, effectively rendering older devices that still rely on the network useless. These are the choices that are made for quality of service reasons. And lastly, another forgotten metric to consider is how many clients the network will be required to support. Often a business is just concerned with signal coverage and don't consider the density of the client load. Say, okay, well, I can get it all the way in the corner, but how many people are over there? And security is an important design question that's often taken for granted, as security is, because, well, a password is a password. What more do I need? The real problem is, are you prepared to securely integrate your wireless network? For example, a guest network needs to be segregated from the corporate network. It needs to be encrypted, and if possible, should be integrated with Active Directory. This means that to gain access to Wi-Fi, a user needs to have network credentials. This goes significantly deeper than just having, the Wi-Fi password. Authentication happens at the Active Directory level, and the encryption handles the protection of data. There's several stages to the design and integration process. There's a theoretical on-paper design, a survey that confirms the design, and then an installation and a validation survey. The predictive placement is the on-paper design. Using software to help build a virtual environment, an abstract design can be created based on a simple floor plan and the previously identified network throughput and density requirements. We can create a heat map that shows the various details such as the signal coverage, interference, and highly utilized areas. The pre-deployment survey, before any installation, it's important to verify the design is going to function. So we do this by completing a pre-deployment survey. The pre-deployment survey is used to take field attenuation readings and make adjustments to the final design once you actually get in the physical space. Once the APs are in place, there's one final sweep to ensure the newly installed devices are all connected and all work as intended. That's where the finer details of airtime utilization and interference get perfected. So for attending this webinar, we're offering a complimentary wireless survey to you at no cost. It's a non-technical survey that will include a 1-hour on-site visit to take a look around and see what's already built, gather information. We can offer up a report of suggestions on how to improve your current wireless environment. If you're interested in this offer, you can reach out to Ashley at info@tcsusa.com, or you can just type Wi-Fi in the chat box. And let me know if there's any questions.
Thank you, Ian. We'll go ahead and take time for some questions now. Just a reminder, please be sure to type those questions into the question box in your control panel. We'll wait a minute or two to see if we have any questions come in. All right, it looks like we've covered everything. Ian, is there anything else you'd like to include before we go?
Nope, that's it. Just want to thank you for participating.
Great. Thank you, everyone. We appreciate you being here today. Thanks again for joining us, and we'll see you guys next time.